Okay, so today's objective is to continue to learn about the potential and kinetic energy and basically learn how the law of conservation of energy actually works. Our essential question is the same as the last one, so these are notes that should be on page 147. Make sure you ignore this page 77 on here. Should be page 147 in your notes. These are the notes that we began on Monday. So remember, the essential question for that was, how would I use the potential and kinetic energy formulas to demonstrate the law of conservation of energy? So just to refresh your memory, remember that the law of conservation of energy is basically, or states, that energy cannot be created nor destroyed. So we went through and we talked about these different things, and we said that when we look at the law of conservation of energy, we are going to have to ignore friction, because friction basically causes energy to be transformed and, in quotation marks, lost in the form of heat or in sound. For example, our lab that we did where we had our tennis ball and we dropped, it hit the ground, but it didn't come back up to our original position, and as we did it over and over again, we saw that each and every time the ball only went up a certain section because some of the energy in the system was being transformed into heat whenever it hit the ground, and it also made sound. So since we're going to ignore friction, we're going to say that even after a bounce, it's going to go up to your original position, which is 100%. So this would be basically like we had something such as this, where we dropped it from that top, which is 100%, comes down, comes back up to the same position, still 100%. So remember, 100% is up at the top, and that's for potential energy, because that's most of your potential energy is at, and 0% kinetic. As it comes down, halfway down, it's going to be 50-50. When it gets to the bottom, you're going to have 100% kinetic and 0% potential. So we are going to look and use these two formulas. We're going to look at the potential energy formula and the kinetic energy formula. So just to review, the potential energy formula is mgh. EP is potential energy. Our unit for that is joules. M is mass. Our unit is kilograms or newtons. H is height, which is going to be done in meters. G is gravity, which is meters per second squared, which actually is a constant because we're always going to talk about gravity on Earth. So it's actually 9.8 meters per second squared. Now when we look at kinetic energy, the formula for kinetic energy is 1/2 mv squared. EK is kinetic energy, unit is joules. M is mass, kilograms or newtons. And V is for velocity, which is in meters per second. So these are two formulas that we will be using. Now, we are going to practice using something called the DUFAS method. But before we go into that, what I need you to do, and you will probably need a flip page, is I need you to go ahead and copy these questions. So I'm going to give you a couple minutes to copy these questions. And they should be part of these same notes. So I want you to ignore this one. Pay attention to that. Alright. So if you look, this is your first question. This is a system. I'm telling you that this ball bounced to 50 meters. Okay? I want you to find the potential energy and the kinetic energy. You know that the mass is 60 kilograms. So this is going to be our first problem we're going to do. And then the second one down here, I am showing you the same problem. You still have potential energy up at the top, kinetic energy at the bottom. The velocity is 20 meters per second on this problem, and the mass is 60 kilograms. So if you look, what you want to do is you want to go ahead and copy both of those problems so we can go through and make sure that I show you how to make or how to do the formulas. So go through and copy those down. I'm going to give you about 1 more minute, and then we will go through and I'll show you how to do the problems. Alright, so you should have already finished copying the questions. Now what I need you to do is I need you to go to page 146, which is across from your notes from page 147. What you're going to do is you're going to do the DUFAS method of answering problems. So these are our DUFAS notes. So I need you to, on page 146, basically you're going to go through and divide that page into 4 columns. The top should say DUFAS at the top. The first column should include D and U. The second column F. The third column A. And the fourth column S. So what we're looking at is we're looking at a way to basically dissect the problem and to make sure that you do the problem correctly and you choose the correct formula. So, if you look at D and U basically stand for diagram and units. So, in that section, when you do the DUFAS method, you are going to draw a diagram and you're going to write the units that go along with the problem that you're doing. F is formula, so basically what formula will you be using? What's going to help you decide the formula is looking at what units you have. A is for arrange. Sometimes we need to rearrange the formula to find what we're actually looking for. And S is for solve. So, if we look at our first question. So, looking at your first question, you can see a couple things. So, you can see that you have this diagram already drawn for you. So, basically, in your notes, if you were doing this on your own, what you would do is you would draw that diagram. So you would just go through and very quickly draw your diagram. Now, obviously, this is right across from the notes that you're taking, but what you're going to want to do is you're going to want to use this method whenever you have worksheets. So you're going to go through and basically just redraw your diagram very quickly by putting everything you know. Now, once again, on your problems, you won't have pictures, so you're going to have to come up with your own diagrams. So going through, you're going to look at what you have on here and basically just rewrite it again. So looking at this diagram, I'm going to find some units. So if I look, I here have mass, and I know that's 60 kilograms. I know right here the EP at 0.3. I'm looking for it. There's a question mark, so I need to find it. So I don't know that. That's going to be one of my variables, but I know that's a unit of joules. I can see that I need to find EK, which is kinetic energy, at 0.5, and that's going to be joules. And then at 0.5, I know that the potential energy at 0.5 is 0 joules. So, if I look at this, and my first question is to find the potential energy at 0.3. So if I want to find that, I know I need to find the formula for potential energy, which if I look at my notes, it's potential energy mass times gravity times height. So that's my formula. Since that's the one I'm looking for, okay, I am going to just basically rewrite my formula because I don't have to rearrange anything. And now I'm going to solve. So how do I solve? I go through and I substitute. So I'm going to go EP is equal to M. Well, my mass is 60 kilograms. I always make sure that I'm going to have my units, and I'm going to include my units. G is gravity. Well, as I said before, gravity is a constant, and it's always 9.8 meters per second squared. And then H is your height. Height is 50 meters. So basically all you're doing first is going through and substituting your numbers. Once again, you always want to include your units. So as I look at that, that's a pretty simple problem. All I have to do is go through and actually multiply all my numbers. So if you will grab your calculator that is out and go through and calculate your numbers to see what the answer is. So if you already did it, what you saw, or what you should have found, is that the potential energy at position 3 is 29,400. Now, if I look at my units, I would have kilogram meter cubed over centimeter squared. But I know that my unit is the joules for energy. So it's 29,400 joules. So that would be your first answer. Now, since this is the potential energy at the top, and we said that we have to ignore all friction, now I know that in this diagram, the total energy at the top is 29,400. The total energy at the bottom is 29,400. So if I know that, then because of the law of conservation of mass, I also know the kinetic energy at the bottom. Since it's 29,400 joules at the top of potential energy, meaning zero kinetic energy, at the bottom you would have 29,400 joules of kinetic energy with zero potential at the bottom. So just with that formula, I was able to find both of my answers to that question. So, looking at the next question. So kind of dividing that and going to the next question. If you look at your next diagram that you had, the second picture that you drew, which is this one. Once again, with DUFAS method, you're going to draw that diagram, so you're going to very quickly go through and on the DU part, just go through and redraw your diagram very quickly. So you're just going to very quickly sketch it. So at 3, you're looking for EP. You don't know what that is. At the bottom, EK. You don't know what that is. You don't know what an H is. Now you do know the velocity of the ball at 0.5, which is 20 meters per second. And you know the mass, which is equal to 60 kilograms. So all those things you know. So then you go to your units. Well, velocity I have 20 meters per second. Mass I have 60 kilograms. I don't know the height, but I know the height will always be in meters. I don't know the potential energy at 0.3, but I know that the unit is joules. I don't know the kinetic energy at 0.5, and I know that is joules. So that's what I know. Now looking at my formula. Well, if I look, I can't use the potential energy formula because I don't have H. I don't have EP. The only thing I have for potential energy is the mass and gravity. So I have two variables, so I can't use that formula. Now if I look at my other formula, which is the kinetic energy formula, kinetic energy is... So once you have all these problems, you are going to figure out what formula you have. And if you go through, you can see that the formula for kinetic energy is 1/2 mass velocity squared. So you're going to make sure that you use that same one. So when you get to this point, you're going to have 1/2 60 kilograms, 20 meters second squared. When you square 20 meters per second squared, you get 1/2 60, 1/2 times 60 times 400 meters per second squared. When you do that, you go 400 times 60, if you put it in your calculator. You will see that it's 1/2 24,000 kilograms meters per second squared. And then when you multiply it times 1/2, it's basically like you're dividing by 2. You end up with 12,000. And since this is kinetic energy, it is still joules. So when you use the formula, you will find that the kinetic energy at 0.5 is 12,000 joules. So if the kinetic energy at 0.5 is 12,000 joules, and law of conservation of energy says that you can't create or destroy energy, then you know by default what potential energy at 0.3 is, which is 12,000 joules. So if you look, now I have EK, I have EP, but I still have one variable right there, which is the height. So we're not done yet. This has to be a 2-section problem. You're probably going to need a flip page for this. So if you do, go ahead and set up your flip page. So you're still using the diagram, but now you know what EP is. So EP at 3 is 12,000 joules. You don't know height, which it has to be in meters. You know gravity, which is 9.8 meters per second squared, because that's all it is all the time. You want to find height, so you're going to use EP mgh. I'm sorry, you also know mass, which is 60 kilograms. So here's where you're going to have to rearrange, because you're looking for h. So this is where you're going to use your algebra to solve for h. So if I look at this formula, and I have potential energy is equal to mass times gravity times height, and I'm trying to get height by itself. Well, I'm multiplying on this side. Since I'm multiplying mg by h and I want to get rid of it, I want height by itself, I'm going to do the opposite operation of multiplying, which is division. So I'm going to divide both sides by mg. When that occurs, this m and this g cancel each other out, which you're ending up with h by itself. Potential energy divided by mg. So this is the formula that you're going to be using. Height is equal to potential energy divided by mass times gravity. So when you get to there, now all you have to do is substitute. Potential energy is 12,000 joules. Mass is 60 kilograms. And gravity is 9.8 meters per second squared. So once you are there, all you have to do is go through and remember order of operations, so I always usually do everything at the bottom first, which means that you're going to multiply 60 times 9.8, which gives you 588. So you have 12,000 joules divided by 588 kilograms meters second squared. And then you're going to divide your numbers, which is 12,000 divided by 588, which gives you 20.4, and I would always go through and round to the nearest hundredths place. So since it's 0.408, you're going to round to 41, and this is height, so you know your unit is meters, and that is your answer. So now, by doing that, in this problem where you had several things missing, you knew that potential, you found out kinetic energy with the formula, which was 12,000. Because of the law of conservation of energy, you know that potential energy at point 3 is 12,000. Once you have that, you were able to use the potential energy formula to find height, and now you know that the height was 20.41 meters. So make sure that you are going through, whenever you're doing problems, you're going through and you're finding every single part, you're diagramming your units, you're looking and finding the right formula, rearranging if you need to, and then whenever you solve and you substitute, remember to go through and use order of operation. So, if you look, basically what I just showed you is how to answer your essential question, which is how would you use both of these formulas to demonstrate the law of conservation of energy. So if you look in both instances, the potential energy at point 3, which is always going to be your most potential energy, is always equal to the kinetic energy at point 5, which is the bottommost point. So make sure that you realize that those 2 points, the highest point and the lowest point, will be equal in energy because of the law of conservation of energy, but it's going to be a different type of energy. Potential energy will be the one that's going to be the most at the top, and kinetic energy will be the one that's most at the bottom. So make sure that you go through and you practice using these problems. You will be getting a skill sheet which will have several problems, and you will need to use the DUFAS method of notes to try and figure out all your answers. Actually, from now on, anytime you have to turn in any corrections on any type of problem, the requirement will be that I see the DUFAS method for every single correction. Have a good day.